Hey everyone, today let's try to solve another LeetCode problem called minimum seconds to equalize a circular array. Basically, in this problem, you are given an integer array like this, nums, and here you can apply an operation for each second to make I plus 1 and I minus 1 to be equals to I, basically. So here we should return the answer 1 second because this is the minimum second that we can turn everything into 2. So the explanation is that we can turn everything to 2 in 1 second. For the first second, these 2 will become these 2. Basically, we are changing the 1 to 2. And this 1 can change to this 2 as well. That's why in 1 second we can make the whole array to become 2. For the second example, the input is 2, 1, 3, 3, 2. The answer is 2. Why? Let's try to turn everything to 3. The first step, we can turn this 1 from here to 3 and turn this 2 from this 3. That's why this and this will become 3. For the second, these 2 can be changed from I plus 1, which currently has already become 3. That's why this 2 will become 3 on the second. And at the end, we need to spend 2 seconds to make everything equals to 3. And that's why the answer is 2 here. So now the question is, how can we determine the minimum seconds that we can spend to turn everything into something? It doesn't really tell us to turn everything to 3 or turn everything to 2. We just have to try to pick an element and turn everything else to that element. How can we solve it? So one key observation is instead of looking the whole array, we try to look at all occurring index for each numbers. By occurring index, I mean the occur one is 0 and 2. It is because this occur at index 0 and it also occurs at index 2. So that's why this is 0 and 2. So let's think about if we pick 1 as the answer and make everything else to become 1, what would happen? What we will see is that we have 4 elements, 0, 1, 2, 3. This 0 and 2 is already an element of 1, but we have to make everything else into 1 as well. That's why if we try first all the indexes from left to right, we basically need to fill in all the gap from the index here to the I plus 1 index here. So basically, for example, here we have 0 index happening at 1, and we also have index 2 having 1. So what I'm trying to say is that everything in the middle should be filled as 1 as well. Well, each step we can do minus 1 or plus 1. So the most difficult part of the gap would be something on the middle. So let's say we have an index 1 here, and we also have an index having 1 here. So we need to fill in all the gaps, and the middle one will spend the most time in order to make this element as 1. So what I'm trying to say is that imagine we have multiple occurrences of 1, and we have to fill all these gaps. and also another gap from the end of the array to the start of the array, because remember, this is a circular array. So we have to fill all this gap, and each time the middle of the gap will tell us what is the most time-consuming part to make this gap to become all the same elements of 1, basically. So here, if we try to take a look at occur 1, it means that we try to make everything else as 1. Then we have here and here. We have to take care of this gap, and we also have to take care of this gap, basically. So we have 2 gaps. So the first gap, the middle, is 1. So we know that we have to spend at least 1 time to make the gap as becoming all 1. And here we have to fill in a gap. So one tricky part is that how can we know the gap from the last one to the first one? The trick is just add another element of 0, but plus the number of n. So you can imagine you will have another pseudo element as 4, and you will try to fill in this gap as well. So this gap basically means the circular gap that we are trying to fill. Well, then we iterate all the gap and find the most time-consuming part, and we kind of brute force what would happen if we choose 1 as the answer. Then we do occur 2. It's basically trying to tell us what is the cost if we pick 2 as the answer. First, again, we have 1 and 3 already being 2. We just need to fill in the gap. So this gap, we have to fill it, and the middle of this gap is just 2. So the distance of 2 to 3, or the distance from 2 to 1 is just 1. So we have to spend 1 unit of time. And here, we add another index for 1 to indicate the circular array, as we mentioned. So we will have 5. And we also need to fill in this gap. So this gap basically are saying the circular gap from the last all the way to the first occurring of 2. So we need to fill in this gap. The middle of this gap is 4, and the distance from 4 to 3 is 1 as well. So in order to fill everything as 2, we have to spend 1 unit of time as well. That's why we should return 1 in this case. Let's take a look at the code implementation. So first, we're going to initialize n as the size of the array. And the worst case scenario is that we just have to span every element 1 by 1. Just basically, the worst case scenario is spanning n seconds of it. So this occur means for each value, what are the indexes that is occurring, as we already discussed. Then in line 6 and 7, we're just gonna fill that occur dictionary. Then for each number of the dictionary, first we're gonna initialize the cur as 0. This cur means the cost that we have to make in order to make everything else in the numbers as num. Then we're gonna append the last one as the first one plus n. This thing on line 11 is to make the array to be circular. Then we're just gonna iterate everything from 0 to the length of the index minus 1, because remember, the last element is just a pseudo element that we add in order to make the array consider the circular array. So it is not actually a real element. So that's why we have to minus 1 in order to exclude it. Then we're just gonna calculate the middle of the gap, because as we mentioned, the gap is the things that we have to handle. The gap is all the elements that we have to make it as number, in this case num. Then the middle one will be the most time-consuming part, because each time we will just do -1 and +1. So for the middle part, it's going to be the most time-consuming to reach. So we just need to know what is the time that we have to spend in order to reach mid. Then we calculate the cost from mid to index I, and then we consider this cost and compare it to get the maximum of the cost that we have to spend. And after doing all here, or the iteration from line 12 to line 15, it means that we have already considered every gap that we have to fill. Then this curve will be the cost to make everything else in the nums as num. Now we just have to take it into consideration that if we take num as the target of the answer, then what will be the cost? And we just compare and get the minimum answer, and then just eventually just return the minimum answer that we have found. And we have considered all the num in the num list. So we basically have to put first all the answer and considered all the possibilities. So the time complexity is O n, simply because for this loop we will iterate everything, and then for this loop it seems like we're doing a nested for loop, but we will only visit each index once. So therefore it is still O(n). For the space complexity, it is also O(n) because of this dictionary basically. So that's pretty much all for the problem and the solution. And I hope you find this helpful. And I will see you next time. Bye bye.